Hi, everybody. I feel like number 7, people are going to have questions, so I'm making the video. A bacteria population P is modeled by the equation P equals 100,000 times 2 to the power of D, where D is the number of days since the population was first measured. Select all statements that are true. Okay, before we read the statements, I want to make sure we understand what's happening in this equation. This is an example of a doubling equation because 2 to the D, that's like 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, eventually 2 to the D power. So like every time you're doubling it because you multiply times 2. And then from here to here, you double it because it multiplies by 2. Here we go, double it multiplies by 2. What's happening, so this part right here, I think of this as the doubling function. And this part, oops, I don't know why I keep moving. This part is how much I start with. So I'm going to start with 100,000 bacteria, okay? So then from here, so because that's 100,000 times 2, but I don't have any of them, so it's just 100,000. And the next one is going to be 100,000 times 2 to the first power, 100,000 times 2, which is 200,000. And then the next one, I'm going to double it again. It's going to be 100,000 times 2 to the second power, so it's 100,000 times 4, so it's 400,000. I'll double it again, 800,000, because that's 100,000 times 2 to the third power. I could skip ahead if I want to, if I wanted to know how many are after like 10 days. We need a calculator for this. 100,000 times 2 to the 10th power. I'm using my calculator. 2 to the 10th power is 1,024. So it's 100,000 times 1,024, which I believe is 102,400,000. Okay. Okay, so let's think about these questions. 100,000 times 2 to the negative 2 represents the bacteria population 2 days before it was measured. This is true. So this is an example. Like I could, if I wanted to. Negative exponents are weird, but they do exist and they are interesting. And I hope we get a chance to talk about them before the end of the school year. But so essentially, if you're doubling going this way, to go backwards, we'd go by half, right? So this would be 50,000, which would be 100,000 times 2 to the negative 1 power. That's what that would be. And then negative 2 would be half of that again, which would be 100,000 times 2 to the negative 2. And if you put it into a calculator, 2 to the negative 2 power is going to be like a quarter because it's dividing by 2 times. And then so 100,000 divided by 2 will give you 2,500 or 25,000. Sorry, I can't read numbers. So number A is correct. The bacteria population 3 days before it was first measured was 800,000. That is false. And I know it's false because it's going to be half of 25,000. It was 800,000 1 week. Oh, sorry, the bacteria population 3 days before. If it said 3 days after, then that would be correct. The population was more than 1,000 1 week before it was first measured. That's a good question. Let's take this. Let's keep going back. So 1 week, it'll be back 7 days. I'm running out of space here, so I'm going to go over here to the side. And this is my day and my population. And so I'm just copying this first number over. So this is 2,000, sorry, 25,000. And then going backwards is going to be half. So 25,000 divided by 2 is 12500. Divide that number by 2. 6250. Take half of that. 3125. Take half of that. 1562.5. Take half of that. 7812. So no, so 7 days, like a week before, it'll be less than 1,000. But it was close. The population was more than 1,000,000 1 week after it was first measured. So 1 week after will be, this is going to be D equals 7. So we can do 100,000 times 2 to the 7th power. 2 to the 7th power is 128. So it'll be 100,000 times 128, which is going to be 128. I'm losing track of my zeros. Yeah, that makes sense. 12,800,000. So yes. And then E, the bacteria population 4 days before it was first measured. We actually did that calculation. 4 days. That's correct, because it's right here. Right there. 4 days before, 6,250. Negative exponents are weird. They are weird things to think about. But one way you can think about a negative exponent is if a positive exponent is like multiplying, the opposite of multiplying is division. So you could think about a negative exponent as dividing instead of multiplying. There are other ways to think about it too, but I like the dividing way. I hope that was helpful. And great. Have a great day.